Good morning, guys. This is Vida Robinson. I'm going to be performing your third experiment called extraction. Extraction is one of the most important techniques for isolating and purifying organic substances. In this method, a solution is mixed thoroughly with a second solvent that is immiscible with the first solvent. Rather that immiscible liquids do not mix, they form two phases or layers. The solute is extracted from the one solvent into the other because it is more soluble in the second solvent than the first. The theory of extraction is described in detail in Technique 12, Section 12.1, 12.2. You should read these sections before continuing this experiment because solubility is the underlying principle of extraction. You may also wish to reread Technique 10. Extraction is a technique used by organic chemists, but it is also used to produce common products that you are familiar with. For example, vanilla extract, the popular flavoring agent, was originally extracted from vanilla beans using alcohol as the organic solvent. Decaffeinated coffee is made from some coffee beans that have been decaffeinated by the extraction technique. See the essay Caffeine that precedes experiment 11. This process is similar to the procedure of experiment 3A, in which you extract caffeine from an aqueous solution. The purpose of this experiment is to introduce the macro-scale technique for performing extractions and allow you to practice this technique. This experiment also demonstrates how extraction is used in organic experiments. Alright, with that being read, let's go ahead and start with experiment 3A, which is extraction of caffeine. Alright, let's go ahead and start experiment 3A. So this is the extraction of caffeine from an aqueous solution. So, of course, you see we have our separatory funnel out, which we're going to use a lot today. But I already started by adding this much caffeine into this centrifuge tube. You see it? So it's 0.1693 grams of caffeine into this centrifuge tube. It's already been placed there, and I'm going to add 10 milliliters of regular DI water. Once that's been added, I'm just going to make sure I got all of it. I'm going to shake this vigorously for a couple seconds, trying to get the caffeine to dissolve completely. As you can see, the caffeine does not want to dissolve. You can see how cloudy it is. You can probably see the particulates still floating around. So I'm going to shake this for a couple minutes vigorously, and I'll see you guys when I get back. Alright guys, we're back. I've been shaking this caffeine water mixture for quite some time now. As you can see, it's a little, hold on, let me get it in frame. It's a little more stirred than it was before. Not as much suspension. I think I got it as dissolved as I'm going to get it. Okay? Now, I'm going to add it using a pasture pipette. Alright, so I'm going to add this using a pasture pipette into my separatory funnel. Got all of it transferred. Boom. Alright. Now that I've done that, set that aside. Now I'm going to add 5 milliliters of methylene chloride, also known as dichloromethane. 5 milliliters that I've put in this graduated cylinder, I'm going to add into my separatory funnel. So I just added an organic solvent to an aqueous solvent, and this is where the extraction happens, okay? So I'm gonna cork it. I'm gonna pull out my separatory funnel so you guys can watch, okay? So what I'm about to do is I'm going to make sure my stopper is nice and firm. I'm gonna invert them and release the gas. You guys hear that? I'm gonna do it again. Here, invert, release pressure. Hear that? I'm gonna do it again. There we go. So I'm just going to do this for a couple minutes. Make sure that I'm releasing the pressure. You can see the pressure is getting a little weaker now. So I feel a little better about starting to shake this, okay? So now I'm going to shake. Not vigorously, not trying to shake the heck out of it, but just trying to get the caffeine out of one mixture and into the other. So I'm gonna rock it back and forth. Let's see if I can get you guys a better image. There we go. I'm gonna rock it back and forth, trying to get those two to line up. And now, see, I shake, and you see no emulsion has formed, right? Two clear layers. I'm just gonna keep shaking for about a minute, okay? Shake, shake, shake. I'm gonna check the pressure. Yeah, there we go. Shake, shake, shake. Make sure you guys can see. Just gonna let it come back down and separate out again. Make sure I don't have an emulsion. As you can see, there are two clear, distinct layers with no third layer in between. So I'm going to shake this a little longer and then I'll bring you guys back. Alright guys, we're back. I shook it vigorously for a little while. As you can see, I have it sitting in my iron ring, and now I'm about to do the extraction, okay? Well, the extraction already happened. Remember, the goal was to pull the caffeine from my aqueous water, right, from the aqueous solution, pull it into my organic, since it's more soluble in the organic substance, the organic solvent. So now I'm going to pull out this bottom layer. This bottom layer, I'm going to pull it out, add some more methylene chloride, do it all over again, okay? So I'm just going to pull out this bottom layer of methylene chloride. So I'm going to open my valve. There we go. Alright, so I've pulled out the methylene chloride. And now I'm going to do it again, add more methylene chloride and run it again. Alright guys, we're back for the second extraction. I'm going to do the same thing. I already added 5 milliliters. I've shaken it up a little bit, and now I'm just going to move the methylene chloride, this bottom section, down into this flask with the rest of it. Second extraction. Let's try to be a little better than the last time. Watch the line move down. It's going to move slowly. You see it right here? Moving down, down, down the separatory funnel. rotate it down, put it all the way down at the very bottom, and closed. I'll take that last drop. Here you go. That was my second extraction. Let me back up. Yeah, that's my second extraction. I'm going to go one more time. So I'm just going to add 5 milliliters of methylene chloride back into the top, shake it up again, pull out the bottom one more time. Alright, this is the third extraction, my last one. So in this one I'm going to do the exact same thing, except I'm going to make sure I get every drop of the organic out. Alright, it's okay if I get a little bit of the aqueous because I'm going to end up drying this liquid in a second. So I'd rather have a little bit of the aqueous in my organic than have any organic left here in this separatory funnel. So I'm just going to do that now. You can see the line moving. It's moving, it's moving. I have it at a steady drip right now. Being close. I'm gonna just pull a little bit, make sure I get every drop of the organic. Up and close. Alright, now if you look at this funnel, you can see there's no lines in it, which means I got all of it out. But if you look right here, let me show you the methylene chloride, caffeine. If you see it right there, you see there's just a little bit of layering. It looks like I got just a little bit of water. Perfectly fine. I'm going to dry it in a second. I'll see y'all then. Alright, now I'm just going to add some anhydrous sodium sulfate to my wet methylene chloride. By wet, I just mean that it has water in it, okay? So yes, it's a liquid, but it is only wet because of this tiny layer of water in it, okay? So what I'm going to do is I'm going to add this until it doesn't clump at the bottom, and I'll show you what that looks like. And then I'm just going to let it dry, and then we'll come back. So I'm just going to add a little bit of this at a time. See, I'm just going to scoop maybe, maybe that much. Okay, and I'm just going to add it into my Erlenmeyer flask. You see it at the bottom? So you see how it's clumping there at the bottom? Here we go, this is what we really needed. A nice scoopula. Yeah, that should be good. And you can see there at the bottom, if I stir it up, spin it around, maybe a little bit of clumping, I'll add one more spoonful. But it looks pretty dry to me. And it's really something you just get the feel for. I know my first time doing it, I was pretty unconfident, but the more you do it, the easier it gets. So, I want you to look with me. If we look there, I'm not seeing as much of a line. If I look down at the bottom, you see how it's clumping down there? That means it's still soaking up water, right? So this sodium sulfate soaked up that water into there. But you can see all these free crystals, they don't have any water to soak up, right? So I think I'm gonna add one more spoon just to be sure, because I really don't want this wet at all. I really don't. And then I'll move it to try to extract just the caffeine. One more spoon. There we go. Trying to dry this liquid out. So you see when I turn it, we still have some free flakes now. There's clumps, but some of them move very, very freely. That's what we're looking for. And if I could show you down the barrel, you'll see that when I stir it, it's all pretty free. So I'm just going to let it all settle down at the bottom. Then I'm going to pull up my dry methylene chloride, and then we'll move on. Alright guys, we're back. I went ahead and pre-weighed this Erlenmeyer flask, and you'll get the weight when I give you the final data for everything. But right now we're going to pull out this dry, clean methylene chloride using a pasture pipette, okay? So I'm just going to transfer it using a pasture pipette from here into here. So to do this, what I'm going to do is I'm going to tilt it on a side, okay? I'm going to insert my pasture pipette. I'm just going to suck up the top, put it in there. Off the top, into there. Sorry, I move faster, but I'm trying to make sure you guys can see. So my goal is to not grab any of the drying agent. So I do that by just moving the flask around, trying to get the drying agent stuck on the sides. You see how it's stuck on those two sides right there? Oh, how it's stuck on those sides there. So I'm going to move the liquid to another side and pull it off. If I did grab any drying agent, it would mess up my... Ooh, that was bad. My percent yield calculations. That's why I'm trying to be very careful. There we go. As you can see, just drying agent left there at the bottom. I don't see any liquid, so here's my dry methylene chloride. Now I'm going to add this flask right here to that beaker that's at about 45 degrees Celsius. I mean, all that water is at about 45 degrees Celsius, and I'm going to run an air tube into it. See if you can hear it. To try to dry it out. I mean, evaporate off all the methylene chloride. Maybe a little less power. So I'll just work like this until it all evaporates off, and I'll come back to you guys then. Alright guys, here is the flask after evaporation. As you can see, it looks like the caffeine that we took in the beginning. So now we're just gonna go place it, tear our scale, place it on the scale. There you go. Here's your final data for experiment 3A. This was our initial mass of caffeine we added to the water, the mass of the flask, and then the mass of the extract plus the flask. So this is about an 89% yield of what we put in and what we got out, which isn't too bad. All right, on to experiment 3B. Alright guys, we're going to go ahead and start experiment 3B. Experiment 3B, I added in succinic acid into this centrifuge tube. It's in there right there at the bottom, you see it. Added about 0.1022 grams of succinic acid. That's what's sitting down here. You'll get the exact measurement at the end after I show you the data. To this, I'm going to add 4 milliliters of dichloromethane or methylene chloride and 4 milliliters of DI water. I'm just going to do that now. Dichloromethane. Just going to add that in there. Oops. Okay, set that down, and then 4 milliliters of water. And since these are going in the same tube, I don't feel extremely bad about it. Then rinsing this out immediately after. 4 milliliters of water added right there on top. Boom. I'm going to rinse that out. So right here in the centrifuge tube, you can see 2 layers. Hold on, let me help you out. Yep, there we go. You can see 2 layers. So I'm just going to shake this until it's fully dissolved. Then I'm going to extract the organic into an Erlenmeyer flask, dry it, put it in a test tube, evaporate off the methylene chloride, and then we'll see what's in it. Alright, I'll see you guys after I finish shaking this. Alright, we're back to experiment 3B. As you can see, I have evaporated all, come on camera, I've I've dissolved all the succinic acid into this suspension of both water and methylene chloride. This up here is water, that's methylene chloride. It looks as if it all went into methylene chloride, which is expected since succinic acid, maybe. I won't speculate just yet. So what I'm going to do is I'm going to pull the methylene chloride off the bottom layer, put it into this flask. I'm just going to do that now. So to do this, let's see if I can get a good shot of it. Okay. To do this, I'm going to put my pasture pipette down in the bottom V, like that. First I'm going to release the air, and then I'm going to put it in the bottom V, and I'm just going to pull up that bottom layer. Boom. Just going to do the same thing. Make make sure it's in your purview. All the way, boom. Got a little water in there. All right, and if you can look now, no methylene chloride in there, no layers. I got it all in here. And if you can look through and see, my hand in front of it like a beauty guru. If you can look through and see, it doesn't look like there's 2 layers, but I'm still gonna dry this anyway. It's gonna be the same procedure for drying. I'm just gonna add my drying agent, anhydrous, come on, anhydrous sodium sulfate until it doesn't clump anymore, really. But I don't think it'll take long to stop clumping this one. This looks pretty dry. Just gonna use my scopula, boom, add a little bit. If you look, see, yeah, look there, I really don't see any of it clumping. It looks all pretty free. Did you see? Yeah, it all looks pretty free. I think I'm good. So, now that that's done, let me close and seal everything. Throw this pasture pipette out. Now, I'm going to pull this dry, clean methylene chloride out of this flask, put it into this test tube that's been pre-weighed, and I'm going to evaporate it, and I'm going to heat it, and just evaporate off all the methylene chloride. So same procedure as before. I'm going to just try to pull off all of this methylene chloride. Go. I think got just a little bit left in there. I'm just gonna soak it up. Transfer it in there. Boom. Test tube of methylene chloride, clean and dry, no water. Alright. I'll be back in a second. Alright guys, we're back. As you can see, I have the methylene chloride test tube sitting in a water bath. Yeah, I have the temperature on. The methylene chloride should evaporate below this temperature, but the water still needs to come up to temperature. What I'm about to do is I'm going to turn on my airstream. Hopefully you can hear it there. I probably can turn it down. Yeah, like that. And I'm just going to place it into my test tube. Try to get it to evaporate a little faster. I'll let y'all know when it's evaporated all the way. Alright guys, this is the test tube after evaporation. As you can see, it doesn't look like there's anything in there. My prediction might have been wrong from the beginning. Because if you remember, succinic acid has 2 carboxyl acid groups, which means it would be highly soluble in water and not very soluble, if ever soluble, in an organic solvent like methylene chloride. But let's weigh it and see if there's anything at all in there. Alright, there you go. Alright, this is experiment 3B. This is your data that you need. As you can see, it doesn't look like we pulled out any succinic acid in the methylene chloride, which theoretically is expected. Alright, let's move on to experiment 3C. Alright guys, this is experiment 3C. This is experiment 3C. We have three mixtures here: water and N-butyl chloride, water and N-butyl bromide, and N-butyl bromide and aqueous sodium bromide. Okay? So this is what test tube 1 looks like. You can see, let me do it. Okay, you can see there's two distinct layers. You have to decipher which layer is which. Remember, this is 1, mixture 1. What's the top and what's the bottom? 2, water and N-butyl bromide. We have two distinct layers, you see? It's forming an interesting shape. So, water and N-butyl bromide, which is on top, which one sinks to the bottom? Mixture number 3, butyl bromide and saturated aqueous sodium bromide. Here we go. You see, still two distinct layers. Question is, which one floats, which one sinks? That's the end of experiment 3C. Alright guys, this is our last experiment, experiment 3D. I put in here about 0.36 grams of unknown A. And to it, I'm going to add 10 milliliters of diethyl ether to dissolve. You can see it there. Just going to screw this on and shake it. Going to dissolve it all the way. Get back to you guys when I'm done. Okay, as you can see, I've dissolved all of unknown A into the diethyl ether, and I'm just going to add it to my separatory funnel, making sure it's closed and clean. There we go. Add it all in. Alright, now I'm going to add 5 milliliters of 1 molar. Hello. Yeah, 1 molar NaOH. 5 milliliters into the separatory funnel. Just like that. I'm gonna put the cap on. And remove it. Now I'm just going to shake it. I'm just going to shake the separatory funnel like I did for experiment A, and then I'll see you guys back for the extraction. Alright guys, I'm going to go ahead and pull out the bottom layer, and this is going to be my first NaOH extraction. Okay, so I'm just going to pull it out into this Erlenmeyer flask. You guys can watch it divide, or watch it extract. Now I'm just going to do it all over again. Add another portion of NaOH and then extract it one more time. I'll see you guys when I'm done. Alright guys, these are the two extractions. This is the first NaOH extraction, second NaOH extraction. You can see my ether is still sitting in there. I'm just going to cap it, make sure nothing evaporates off, okay? So now we're going to check these for impurities, okay? We're going to do this by adding acid, 6 molar hydrochloric acid to be specific, to each, and see if precipitates form. So, to the first one. I added it, and you can see it's gotten pretty cloudy. Let's check and see if it's acidic. I'm just gonna take a few drops, put it on this blue litmus paper. Nope, it's still very basic. So, add a little more. You can see it's a little cloudier. I'm gonna add about 1 more milliliter. All right, now we're gonna check the pH. Light pink. There we go. It's acidic, and as you can see, especially comparing these two, you can see more precipitate cloudiness in this one than in this one. So let's check the second extraction now. Okay, I'm gonna add about 2 milliliters in of the 6 molar hydrochloric acid. As you can see, not a lot in there. I'll check the pH. Hold on, let me clean this off. There we go, nice and clean. Stir it up, check the pH. Acidic, as you can see. But you see there's less condensation. Let me zoom in. Yep. Less condensation in this one compared to this one. Less condensation in the second extraction than the first. And you guys can work out why that is. Okay, now we're going to start drying this ether. But before we do that, we have to add 5 milliliters of supersaturated NaCl before we can start drying it. Alright guys, I'm back from adding saturated NaCl, which you can see there at the bottom. I took it and I shook it up like I did all the other ones. Release gas, shook it up, release gas, you get the idea. So I've been doing all day. Now I'm gonna pull off the NaCl, which you can see right here. Right here, just gonna pull it off, then dry my ether. Second, that's kind of important. Now all that's left in there is the ether. Now I'm just gonna take this ether and put it into another Erlenmeyer flask, and then dry it, and then add it to another Erlenmeyer flask that's been pre-weighed, and then evaporate off the ether, and then all that's left is purified unknown A, and then I'm gonna put that in the melting machine. So I'll get back to you guys after the ether starts drying. Alright guys, I'm just gonna pour. I need to show you guys how you're gonna pour this. Since our extract over, the solvent that our solute is in has been the top layer the whole time, and we've been filtering things out of the bottom. Instead of just putting this flask underneath the separatory funnel and draining it out, I'm gonna pour out of the top. Okay? So let's see if I can get this on here. I'm just gonna pour the ether. Out of the top. There we go. Got my ether. Just like the other experiments, now I'm going to dry it by again using anhydrous sodium sulfate. Just going to add it until it doesn't clump. Boom. Maybe just a little more. Yeah, that's good. I'll show you guys. Here it is. You can see down there. See how loose and non-clumpy it is? That's what we're looking for. Now, I'm going to extract this with the Pasteur pipette. Put it into my pre-weighed flask, which is right here. And then I'm going to evaporate off all of my ether. Here's my Pasteur pipette. I'm just going to suction off this solution. Sorry, I know I'm all up in your face. It's hard for me too. Yep, suction off ether. And you might be able to tell the ether, it looks like less ether than we started with, which is fair because ether, if you remember, is highly, highly volatile. So the ether has been evaporating off as we've been doing this, which means it should be pretty easy to evaporate off in our final step. So suction that in, and it looks like, oh, maybe there's a little liquid back there. I'll go ahead and grab it. You see it back there? I'll go ahead and grab that. Alright, this is what we've been working for. Clean, dry ether with pure unknown A extracted inside. All that's left is to evaporate off the ether and get our unknown A. I'll see you guys in a second. Here we go, guys. It's the finale. Erlenmeyer flask. Ether and unknown A dissolved inside after extractions in NaOH and cleaned and dried. Okay? Now I'm just going to evaporate off the ether by putting it in a warm water bath and adding just a little bit of air. Alright? Can you guys see? Yeah, I hope you do. Let's see what's going on. Yeah, there you go. So I'm just gonna let that sit in there and add just a gentle stream of air and let it evaporate off, okay? You guys get the idea. See you in a second. Alright guys, I have it all evaporated off and you can see this is pure unknown A sitting in there nice and dry. Now we're just going to weigh it. I'm going to tear my scale, add it on there, close the door. There we go. And I'll get you your data in the next clip. Alright guys, here is your mass data for experiment 3D. This is how much unknown I added initially, the weight of the flask, and then this is the mass of that. Okay, now what I'm going to do is I'm going to take what's in this flask, put it into this capillary tube, and check the melting point. see you guys with the results. I just wanted to show you guys what it looks like in the capillary tube. You see it down there? And I'm just gonna put it into this machine and get the melting point. Alright guys, this is the last piece of data you need, the melting point for unknown A. This is what we got. From there, you can use this table in your book to figure out what it was that was in unknown A. Alright guys, that concludes the experiments for today. Thank you for bearing with me, and I'll see you next week.